Okay, continuing with section 1.5. So let's look at this next example, example 4. So part A, it's saying find the solution of the homogeneous system. This the homogeneous system given here. So I actually solved the problem just to save time. You should be able to do all this work by yourself. So we get this is our reduced row echelon form, and we find here that x3 is the free variable. So writing x1 and x2 in terms of x3, we end up getting our solution as t. Each variable has the value t. Now we can factor out the t by scalar multiplication property. So inside we are left with 1, 1, 1 as the components of the vector. So what is the solution? So note here, solution x is equal to t times a vector. We can call this vector any name v, then our solution is tv. If you recall from before, we say what is this? Geometrically, this represents a line that is passing through the origin and through v. So this would be actually whole line. You can extend it however in R3. Okay, now B part, now solve the following system and write the solution in parametric vector form. And then we will describe as well. Okay, so I went ahead and did the row reduction and I found that my resulting matrix is this, and I write the equation. So I am getting first from the first equation that x1 minus x3 equal to -7. So x1 will be -7 plus x3, substituting x3 t in place of x3 or changing x3 to t, I get x1 equal -7 plus t. In the same way, x2 is -1 plus t. So when I put it in my vector form, the first coordinate or the first component of the vector is -7 plus t, which is x1. x2 is -1 plus t, and x3 is just t. So you can think of it as 0 plus t. Now I will split the solution into vectors. I get this looks like sum of two vectors. One is -7, -1, 0, and the other one is t. Now as before, we can pull out the t, so the answer will be, so where the first vector is p, call it p, and the second is the v, so we have written it as p plus tv, which is the parametric form. So now let's look at what it means graphically or what it means geometrically. Okay, so initially we saw that this purple line is denoting the solutions of homogeneous case. This is the homogeneous case, or I should say Ax is equal to 0. This is the solution for Ax is equal to 0. And this green line is the solution of Ax is equal to b. Why? The reason is that if I have b as in the case of p plus tv, so v is one of the solutions of the homogeneous case, and p is the particular solution, which we found by which is the solution of the non-homogeneous case. So I have v, then I have p. So what does p plus tv show, or how can we use that? Well, this is showing that p is not multiplied by any number. P just stays p, whereas v can be multiplied by We can look at multiples of v but not of p. So it means anytime we add, we can find p plus v, we can find p plus 2v, p plus 3v and so on, or p minus v, p minus 2v and so on. So these will result in a new vector. So where is that vector? So if you notice, every time you will notice that the vector is coming on this line, green line, because if you complete the parallelogram, for example, this first one, this is where the endpoint of the vector is. Similarly, if you do p plus 2v, then our parallelogram will be this one. So we are again arriving at on the green line and so on. You can check that. If you do p minus v, you will find the same thing, that we are arriving at the green line. And so we say that the solution in the line in R3 through P parallel to V. Okay? So this is line, previously the solution of the homogeneous system passed through the zero vector or passed through the origin, but this new one is a translation of the same solution. It is translated by P, vector P. So that is what we will write. The solution of Ax is equal to P. B is a line through P parallel to the solution of Ax is equal to 0. Let's look at another example. It says describe and compare the solution sets of these two equations. So what are these? If you notice, they are the same equation, that this first one is the homogeneous system and the second one is the non-homogeneous system. So I did the work. You can see it is something we did earlier. So we get two vectors and we have two free variables. So I did my algebra, and I found that the x or the solution of the homogeneous case is this. What is that? That is a linear combination of these two vectors. If we call one of the vector u and the other vector as v, then this is the what we will get, and a solution will be the plane which is spanned by these two vectors u and v, and it passes through the origin. That is important, that it passes through the origin and it is spanned by u and v. So now this is another way we could write what we were mentioning earlier. We said a plane passing through u and v and 0. It is the same thing as a plane spanned by u and v. In the non-homogeneous case though, doing our work, we found out that our solution will look like this. Now we have three vectors. So you notice here the vector being multiplied with s is u as before, and then the other one is v, and we have a third vector. Now we name it p. So then this is p plus su plus tv. What is that? That will be the solution, same thing as what we have before, but it will be a plane that passes through P, so not through the origin. So this plane does not pass through the origin. Okay? The case in the solution of the non-homogeneous system. So it is a plane which will be parallel to the plane which is the solution of the homogeneous case, but this new one will be shifted or will be translated P units. So in other words, we can say it is the plane that passes through P and is parallel to the solution of the homogeneous system. This is what you need to be able to explain. So that is it for 1.5.